Okay, so just to review what we talked about with part 1 of this lesson, I introduced natural logs. Natural logs is a log with which base? E. So natural log is a log base E. A common log is a log of base 10. So if I give you uh, an example from part 1, so let's say I said, I want you to do E to the ln of x, and I want you to solve that. Until you get comfortable with this is the same thing as saying E, and ln of x is just a natural log with a base of E. So that would be log base E of x. Then if we have a base of E raised to a log base of E, what was the answer? The answer is the argument, which is x. Okay, so this answer is equal to x. So we talked about that in part 1. The other thing we talked about, does anybody remember what the ln of E, the natural log of E from yesterday is? It's 1. And then if you don't see that, you say to yourself, okay, ln of E is the same thing as the log base E, argument is E. And then E to what power would give you E? So if I give you log base 2 of 2, 2 to the power of 1 will give you 2. So E to the power of 1 will give you E. So ln of E is 1. Let's review from some solving from 30-1. So these would all be 30-1 questions. And then I'll add in some natural logs into this. So log base 5 of 125. So there's two ways that we could do this question. You could say 5 to what power will give you 125. So what is that answer? 3. 5 to the power of 3 will give you 125. Or the other way that we could have done this from 30-1 is log base 5 of 125 is equal to x. And we want to get out of log form. We can get out of log form by going into exponential form. So getting into exponential form, it would be 5 to the power of x. Getting out of log form and rewriting this as an exponential equation, it'd be 5 to the power of x is equal to 125. And then we wanted to get the same base. So I have a base of 5 here. I want to get this to be rewritten as a base of 5. So on the left-hand side, I have 5 to the power of x is equal to 5 to what power would give you 125? Well, 5 to the power of 3. And then once you have the same base, remember we could drop the base and equate the exponents. X is equal to 3. So sort of two ways that we could do this question, but no matter what, we get an evaluation of 3. Okay, this one here, 8 and 16. I want to solve using this method here. I want to have the same base on each side, and then if I get the same base on each side, I could drop the base and equate the exponents. 8 and 16, what base are you going to reduce both of those to? Base of 2. So 8 could be rewritten as 2 to the power of 3, and 16 could be rewritten as 2 to the power of 4. So what I've done is I've just rewritten 8, but there's still, that's raised to the power of x plus 1. So I'm going to put that outside the bracket. And this is a binomial. Binomials deserve brackets. 16 is rewritten as 2 to the power of 4. And then the binomial, it's raised to the power of 3x minus 2. Now, I don't want to drop the bases just yet. I want to do power to a power. Power to a power is multiply. So I'm going to multiply this 3 and distribute it into the bracket, and I'm going to multiply and distribute this 4 into the bracket. So then I will get 2 to the power of 3x plus 3 is equal to 2 to the power of 12x minus 8. Once your bases are the same, you could drop the bases and equate the exponents. So 3x plus 3 is equal to 12x minus 8. Let's bring our x's to one side. Are you guys bringing your x's to the right? Okay, so let's add 8, and we'll get 11 is equal to minus 3, 9x. And x is equal to 11 over 9. If we had a calculator, we could verify by typing in 8 to the power of 11 over 9 plus 1. That would give me the exact same answer as 16 to the power of and I put an 11 over 9 here. Okay, look at the 9 and the 27. What base am I reducing this to? 3. So right now, 1 over 9 is 1 over 3 squared. 27 base 3 is 3 to the power of 3. And then raised to the power of 2x minus 5. I essentially have a base of 3 and a base of 1/3. Do you remember what I'm going to do to this left-hand one? Yes, you're going to bring this 3 up, and it'll be 3 to the negative 2. And then you've got base of 3, base of 3. So if you bring and reciprocate, we would get 3 to the negative 2, x plus 1 is equal to 3, I'll distribute this at this stage, 6x minus 15. And then once I distribute this, my bases are the same, so I could drop my bases and equate my exponents. I'll get negative 2x minus 2 is equal to 6x minus 15. Let's bring our x's to the right-hand side and bring negative 15 over to the left. And I'll get 13. And then x is equal to 13 over 8. Okay. Natural log of e to this power is equal to 8. So first thing before we solve this one, let's actually above it write this one. Natural log of e squared. Remember yesterday we did the power law? And we could take this 2 and I could move it and become the coefficient of the natural log. So 2 times the natural log of e. And what did we say the natural log of e is? 1. So this is 2 times 1. That answer is 2. So if you have an argument and the argument is raised to a power, we could use a power law to bring that power to the front. So this one here, natural log of e raised to this power. Now the power is a binomial, so put it in a bracket. That to the front. So it would give me 3 minus x. The natural log of e is equal to 8. The natural log of e, Alex, is what? It is 1. Natural log of e is 1. So that means it's 3 minus x times 1, which is 3 minus x. Because it's 3 minus x times 1 here is equal to 8. 3 minus x is equal to 8. So let's bring x to the right and subtract 8 to the left, and we'll get x is equal to negative 5. Okay. Let's actually, this will be a nice verify. So let's show this one algebraically by verifying. So I want you to rewrite this and put negative 5 in here. So the natural log of e to the 3 minus 5. So just write that. Okay. That gives you the natural log of e to the power of 8. We know that I could bring that 8 and write it as the coefficient, e times the natural, 8 times the natural log of e. The natural log of e is 1. 8 times 1 is 8. And that's what we got over here. Okay, so there's showing like my proof. Okay, this one here, it's a little bit harder to see, but I want you to see, if I said to you, get out of log form, because this is technically in log form into exponential form. So remember how we did that with this example here. To get out of log form, it's the base raised to this power to the argument. So let's think about this one for a second. It's harder to see this written as a natural log, but you might be able to see it if I say natural log is just log base e. 3x minus 1 is equal to 2. Do you guys see how you would get out of log form into exponential form? Akil, what would you write? Yeah. E squared is equal to 3x minus 1. And we need to solve for x, add 1 to both sides. E squared plus 1 is equal to 3x. Divide by 3, divide by 3. X is equal, because remember E is just 2.71, right? So it's E squared plus 1 all over 3. That's as far as we would be able to answer. Your calculator has an E button, and it has a natural log button, actually. So natural log button is right here, right? So natural log button is there. And then your E button would be this guy. So I'm just going to do open bracket. Here's your natural, or your E. And then so E squared plus 1. And then that guy divided by 3. Okay? So that would be your answer if we were allowed to do that. Okay, this one right here. I'm going to show you two different ways that we could do this one. One way is to write this as a log. So one of the methods that we did in 30-1 was to write this as a log. So how we write this as a log is log, what would my base be of the log? 2. Argument, Sarah, what's my argument? So base of 2, argument would be 3 equals, Maya, x minus 5. Okay. We are solving what x is, so let's add 5 to both sides, and we will get log base 2 of 3 plus 5 is equal to x. So that's what x is. And then one other thing I just want to, because our other answer is going to look slightly different from this. Do you guys remember change of base from 30-1? So I'll show you what change of base is. I could rewrite this as change of base. What it would look like, it would be the log of 3 over the log of 2. Basically, change of base turns it into a common log. So right now this is a log with a base of 2, but if I want to type this into my calculator, and let's say I didn't have this, I didn't have a button to give me to type in base of 2, I could type in the log of 3 divided by the log of 2, and I'd get the same answer. Okay, so log of that plus 5 is equal to x. So this is one method that we could solve, and you could solve this method if you want. The other method that we did in 30-1 is we logged both sides of an equation. So what we have is we have 2 to the power of x minus 5 is equal to 3. I won't change anything if I log both sides. I'm not changing the equation by logging both sides because I could get rid of this log by dividing it out, right? So I'm not changing anything. So what I want you to do is I want you to log both sides. Then let's apply our power law and bring that to the front. So x minus 5 is equal to x minus 5 times log of 2 is equal to log of 3. We want to get rid of the bracket, so I want to distribute in the x and the negative 5. So that would be x times log of 2 would be x log of 2. And then minus 5 times log of 2 would be minus 5 log of 2 is equal to log of 3. Okay. From here, we want to isolate x. So get rid of this minus 5 log of 2 by bringing it to the other side. So x log 2 equals log 3 plus 5 log 2. Now I want to get rid of x by dividing out that log of 2. So I'm going to divide this by log of 2, and I'm going to divide each of these by log of 2. Then I have x is equal to log of 3 over log of 2, log of 3 over log of 2, plus okay, so you have to be comfortable with both. Okay, let's do this guy. We could do a couple of things. So if we convert to log form, let's do this a couple different ways. Oh wait, converting to log form would give me, just let me see, maybe we don't want to do that. Let me just double check. Log, what would my base be if I go to log form? Log base E, argument would be, actually this is one, we could do this. Yeah, argument would be 1/2. It's equal to, what would it be equal to? Negative x. I need to get x by itself. And actually, before I get x by itself, what is log base E? Log base E is ln. Okay, so log base E is really ln of 1/2 is equal to negative x. I want to divide out that negative x, so I'll get x is equal to negative ln of 1/2. Okay, so that is going to be my answer, but I'm going to show you a different way to get that. So we could have written this as a log form. The other thing we could do is we could log both sides, except we're not going to log both sides because we've got e here. Do you know what I'm going to do to both sides? I'm going to ln both sides. Because if we have, it's the same thing as logging both sides. I'm going to natural log both sides. So I'm going to put an ln and an ln. So what I will have is I will have the natural log of e to the negative x is equal to the natural log of 1/2. What do you want me to do from here? So think about what I did when I logged both sides. I brought the power to the front. What will I do for this one? What goes to the front, Owen? Negative x. This goes to the front. So I get negative x natural log of e is equal to natural log 1/2. Maya, what's happening now? Yes, except what is ln of e? It is 1. So I could just do negative x times natural log of e is just 1 is equal to ln 1/2. So that's just negative x is equal to ln of 1/2. Abby, from here, to give me x is equal to of 1/2. Are you guys good with that? Okay, what do you want to do here? Ln of e squared Julie. We could, or do something with this 2. What could we do with the 2? Yes. Reason why you kind of want to look at that always as an option is because then we're left with ln of e. And as soon as you got ln of e, you have 1. So that is equal to x. So Sarah, what is my answer going to be? X is equal to 2. Because it would be 2 times 1 is equal to x. X is equal to 2. Yes. Okay. This one here, let's do the same thing. Actually, no, let's not. Yeah, we can't do that because, yes. So before I do that, I do want to bring this guy to the front, but before I do that, what am I going to do to both sides of the equation? Yes, I'm going to natural log both sides. Okay? Yes, if there's an e, you want a natural log. Yeah, because the natural log of e is 1, right? So if there is an e, we're going to log both sides, but if there's e's involved, we're going to natural log. So we're going to natural log this, and we're going to natural log x. Then let's pull this to become the coefficient. So 4 natural log of 3 times, I will have ln of e is equal to ln of x. from here, ln of e is 1. So this becomes 1. And then I've got 4 natural log of 3 is equal to ln of x. So that would be 4 ln of 3 is equal to ln of x. Okay, now we got to figure out, well, what do we do from here? So I want you to put the 4 back on for a second because I'll show you something. If you put your 4, ln of 3 to the power of 4 is equal to ln of x. If you have the natural log of both sides, you could drop the natural log and equate the arguments. So if you get where you have a natural log is equal to a natural log, you get to drop them and you get to equate the arguments. So the arguments would be 3 to the power of 4 is equal to x. X is equal to 3 to the power of 4, which is 81. Okay. Let's look at something else from 30-1, and then we'll change that to natural logs, and then we'll do a couple graphs. Express the following as a single logarithmic expression. So there was the product law and quotient law, so I'll just quickly show you. If I said log base 2 plus log base 3, sorry, log of 2 plus log of 3. If you have the same base, and these would be common logs, so this would be base 10, we could use the product law to join these two logs together. And this would be the same thing as the log of 2 times 3, which is the log of 6. Okay? Now, before we could join logs together using either the product law or the quotient law, you want to have nothing in front of your log. You want to have a 1 in front of it. So get rid of this 2 by putting it back on the x. Get rid of this 1/3 by putting it back on to the y. And this 4, we're going to get rid of the 4 by putting it on the x minus 2. So I would have the log of x squared plus the log of y to the 1/3 minus the log of x minus 2 to the power of 4. This is equal to, I've got a log base 10, log base 10, log base 10. I could join these all into one log. So log base 10. Remember from 30-1, if your log was positive, so this log is positive, the argument goes on top. So x squared. This log is positive, so the argument will go on top, y to the 1/3. And that should make sense, right? Because if I just give you these two logs and tell you to join them together, you're going to say they join together by product law. It would be this argument times this argument. We multiply those two arguments together. That's why they're on top. This log is negative. Negative is going to employ the quotient law, which means the argument will go in the denominator. And we'd get x minus 2 to the power of 4. And now this is my new argument. And then I could rewrite it if I want to. Y to the 1/3 is the third root of y. So if I want to get rid of rational exponents, I could rewrite that as the third root of y. Okay? Now, we could separate logs as well. So if I gave you this, I could say, okay, separate this guy by, it would be the log of x squared plus the log of the third root of y. This is on the bottom, so then it would be minus this guy. So this one here, we're going to expand using log laws. Now, this is still it's a natural log, but it's a log base e, right? So how I would break this apart is I would say, okay, these two are on top, so it's going to be the natural log of square root of x plus the natural log of 5y. Okay, so put that guy in a bracket. This is on the bottom, so then minus the natural log of z. And then this guy's on the bottom still, so minus the natural log of 3x plus 1 squared. Because again, if I gave you just this, you can combine it into one natural log. This goes on top, this would be on top, this would be on the bottom, this would be on the bottom. Now what we could do is we could clean up things a little bit. So this is equal to the natural log of x to the 1/2. The reason why we want to write that is because then I'm going to eventually bring that 1/2 in front. This could also be broken up into two natural logs. Do you know how I'd break this into two natural logs? Shaywa, what would this be? Of y. Yeah, this can be further simplified. So plus the natural log of 5 plus the natural log of y. This guy right here can't be simplified any further. So this is just minus the natural log of z. This one, I could do something to this, and I could bring this to the front. Minus 2 natural log of 3x plus 1. Okay, and then the only thing I could do further is this. I could bring that power to the front as well. Bring that 1/2 out here. But again, to join all this together, you would bring the 1/2 on the power, bring the 2 up here, then write it as one natural log. If your log is positive, the argument goes on top. If your log is negative, the argument goes on the bottom. So you'll see this on your quiz on Monday, your take-home quiz. Okay, write down for graphing a couple things to remind you. Y is equal to log of x minus 4. Argument x minus 4. Okay, from 30-1, the argument always had to be greater than 0. You could never have a negative argument. So x minus 4 had to be greater than 0. You could never have 0 in your argument, or it had to be a number bigger than 0. From here, if we solve for x is greater than 0. Nope, x is greater than 4 if we add 4 to both sides. And that gave us a vertical asymptote. Logs have VAs. There's a vertical asymptote at x is equal to 4. So this graph at 4, there's a VA, and it's a log graph. So you have to remember what a log graph is. But that would be this will always give us the domain of our log graph. So the domain of this graph is 4 to infinity. And x can't be 4, so round bracket. Okay. Now, it says find the domain and sketch this graph here. So remember, this is just simply f of x is equal to the log base e of x cubed minus 8. So it's a log graph. But we need to figure out what the vertical asymptote or the domain is. It always comes from the argument. So x cubed minus 8 must be greater than 0. X cubed must be greater than 8. X must be greater than 2. This graph, it's a log graph with a domain of x is greater than 2. So that gives me a vertical asymptote at x is equal to 2. So here's my VA. And then it's a log graph. The domain of this graph comes from this x is greater than 2. So the domain of this log graph is 2 to infinity. I'm going to give you one slightly more complicated, and I'll show you how you'd solve it. Yes. It's drawn on the right side because of, I'm going to show you one where it won't be drawn on the right side, but it's drawn on the right side because the argument must always be greater than 0. And it could be drawn on the left, but that would be if we're, like, let's say we had a negative x in here, and then we divide both sides by a negative, it would flip. So if we got x is less than 4, you'd be drawing it the other way. Okay, just whatever your argument is, set it greater than 0, and then solve for x. Okay, watch what happens with this one. This one's going to be a little bit more complicated because it's a squared. So f of x is equal to, this is just basically log base e of x squared minus 1. So then you'd say, okay, this argument, x squared minus 1, always has to be greater than 0. X squared has to be greater than 1. Now, if we square both sides, we're going to get plus or minus 1. Do you guys agree? So I want you to draw a number line, and we're going to get plus or minus 1. It can't be 1. We actually talked about this in pre-calc. We need to find out which regions, we're going to take test values and we're going to plug it in here, which regions would give me, so we know that our critical values are at plus or minus 1. Which regions would make a true statement? So for example, if I pick a number greater than 1 and I put 2, and I put 2 here, 2 squared is 4. Is 4 greater than 1? Yes, that would be a true statement. So that would be true, which means that this is going to be a solution. If I pick a number between -1 and 0, so let's say I test 0, or sorry, -1 and 1, I'll test 0. 0 is greater than 1. Is that true or false? False. Okay, so that means there's no solution within here. Let's pick -2. -2 squared would be 4. Is this a true or false statement? It would be true. So it means that this is my solution. What that means is the graph would look like this. I'm going to have VAs at plus or minus 1, okay, because this is giving me the VAs of the graph. So I'm going to have a vertical asymptote at 1, and I'm going to have a vertical asymptote at -1. So x is equal to 1, x is equal to -1. I need to draw a log graph on the right-hand side and on the left-hand side. So over here, my log graph would look like this. And on this side, my log graph would look like this. How we write the domain of this is if I look at my number line, I'm going from -infinity to -1, union 1 to infinity. That would be the domain of the graph. So when you have squares, draw your number line. Like let's say you had x squared was greater than 4. You're getting plus or minus 2, which are going to give you your critical values. And then you would check on a number line by putting in your numbers left of 2, in between, and right of 2 is how you would do that. Okay, here is the remaining homework. So I'll give you about 10 minutes to do some of this homework, and then we'll start lesson 3, which is the derivatives.